This here is my Visual Studio Windows version of the little Arduino game, Phobos. So on the left here you can see these files here are the game files, and they're pure ANSI-C. They have no platform specific code inside them at all. But what they do have is at the top of here is, if I go down to the bottom, where is it? Haha. There it is. This define for draw sprite. And so the draw sprite in the Windows version is implemented as an OpenGL call, but on the hardware version, on the Arduino, the little teensy 3 thing, it's implemented to write the bytes to the LCD. So if we go to definition, oops, wrong one. Oh, yes. Shazam! So it's just a little fill rect, and if you go have a look inside fill rect, then you can get, it sets up a whole heap of stuff, GL draw pixels. So that's nice and simple. But if you have a look at the, if I just open this up, with the hardware implementation, hooray, we have draw sprite. And that's writing the pixels into the LCD, into my little screen buffer here, which then I use the screen buffer to write straight to the LCD in my update render loop. Now if we run the game here on PC, yes, build, do your thing. Oh, I must have changed something since I last ran this. Huzzah! Then up here, hooray, Phobos. So I've got a little LCD emulator, press to start, and then you can play the entire game using, the keyboard on PC. The other thing I've done is on the PC version there is a little level editor if you press 1. So that writes out the entire level, and then you can, draw maps, whatever. Save your map, and then hooray! So then you can test your maps just as you're writing them. That's quite handy. Now that code, actually, when you save it, it writes out a header file. And if we scroll down here, hooray! Here's the map. And this header file is what gets compiled straight onto the Arduino. So the map. All the map data is just in a nice, on PC it's not const obviously because you have a, you need the level editor, so you need to be able to change it. But on the Arduino code it does come out to be const, and then it just goes into program memory, not heap memory, and it just gets compiled straight in, and the game actually runs off this, like all the map logic and everything runs off this array. And that's the easy way to get it. So then on PC, I just play around, edit the level as I see fit. It writes out the header file, then I just Alt-Tab to the Arduino project, click build, the new map will get compiled in, and it'll run on the hardware. Now this here is the sprites as well, and I have exactly the same thing for the sprites. If you press F2, you can go to the little dude, and you can edit his, edit the player sprite. So let's make him look like this, and then we'll Shazam. There we are, edit both frames. Now when I run around, hooray, he looks like that. It's all very nice and simple, and that's actually a cool little design. I might keep that. But it does let me really quickly prototype the game, design the game on PC, and then I can use all the really nice debugging features of Visual Studio, edit and continue, memory breakpoints, get all the logic really nice and perfect. And then I just have to build the hardware implementation of draw sprite and my update render loop down here, which works out NDT and so forth. And then I just call game.update game.render. And it all simply works. Obviously there's a bit of digital read to get my button inputs instead of WS key state, but all in all it's a pretty simple system, and it lets me just write on PC, but then play on hardware.